like to introduce Droni Kwan. So Droni is with Electric Grid Systems, and he's presenting on their modular and scalable power management platform. So over to you, Droni.
Hi, thanks Tanya for the introduction, and it's my pleasure to be here. And good afternoon. My name is Zhongyi Kwang, and I'm the founder and CEO of Electronic Grid Systems. And today I'm presenting our power management solution for buildings. Next slide, please. Yeah. So brief introduction about us. So we're a spin-off of UofA, and we're a very young company founded in last year. Right now, we're supported by the Green Stamp program by the government of Alberta. And our core idea is to improve building efficiency and power quality with advanced power converters and control. And we're now looking for partners for a demonstration project. And the next slide, please. So the problem we are trying to solve is the high power demand from buildings. And this is a quite painful problem for many building owners because over half of the electricity cost is typically spent on demand charge. And the demand charge is based on the maximum power you use in any day of the month. So that means 15 minutes of high power demand will determine the demand charge of the whole month and even in the next year. So even though you have very little, very small power use in the rest of the time. And in addition, the power demand is measured based on kVA. So you don't have to know what kVA is, but just remember that kVA is the power that includes both real power that you use to do the work and also the reactive power that just runs a high current through your meter and does not do anything. So for example, if the peak demand is 150 kVA, and if the real power is only 120 kilowatts, you actually pay 25% more, and that doesn't make sense. And because of the high demand charge, many building owners have turned to batteries to do peak shaving, but existing battery systems only shave or only reduce the real power. And that means you still need to pay for the reactive power that you are not actually using to do the work. Next slide, please. So our solution is an intelligent inverter-based power management system. It can remove the reactive power without using any battery, and therefore it is much cheaper. And if you want to further reduce the peak demand, you can also use a smaller battery to do that, and to just reduce the real power. For example, if you're using off-the-shelf battery right now, and for example from other vendors like Sonnen or Tesla, you will need more than 100 kilowatt-hour battery to reduce the peak demand number to below 80. To the blue line here, but with our solution, you can only half size battery will be enough. So that means a great reduction in the cost and a significantly shortened payback period. And also, our inverter can improve the power quality of the and voltage quality in the building. So that means you can also save more money by extending the lifetime of the equipment. And next slide, please. So here's a comparison with existing battery systems. Because of our patented circuit and advanced control algorithms, our solution offers more features than other products. And also, if you have multiple EV chargers in the building, for example, if you are running a condo or a business building, it can also help you to manage the EV chargers to keep the peak demand in check. And our inverter is also future-proofed because it's solar ready. And that means if you want to add solar in the future, you don't need to purchase another solar inverter because it's already there. So that's another source of saving as well. And next slide, please. So like I mentioned, we were founded in 2020 and we're pretty young, but our work actually started when we were students at UofA. And we have developed and tested prototypes at different scales from 50 kilowatts to from 50 kilowatts to 200 kilowatts. And we're now looking for partners, for example, building owners or EPC partners to do pilot projects. And also we're looking to have our inverters certified by CSA in Q3 2022. And to achieve that milestone, we will need some funding support, and we plan to apply for grants and funding from various sources. And your support, like for example, letters of interest, letter of support, will be very important for us to get those fundings. So next slide, please. Yeah, so if you're interested in our solutions and want to know more about us, please feel free to send me an email. And my name is Zhongyi Kwang. Here's my email address. Thank you.
Thanks, Joni. Great presentation. Is there any questions right now? Feel free to unmute yourself if there is. There's none in the chat box. Just a reminder to feel free to put questions in the chat box as the presenters present as well, and then we'll bring them forward.
Hey, Tanya, I have a question.
Yeah, go ahead.
Hi, it's Jesse Rowe, Executive Director of the Alberta Energy Efficiency Alliance, for those that don't know me. Thanks very much for the presentation. I'm not an electrical engineer or power engineer, so I don't know the details of the reactive power system that you're using, but I am familiar with power factor correction, which has been used in the past to do this. And so I'm just wondering how your system compares to some of the more traditional power factor correction to reduce that reactive power.
Yeah, so power factor correction, we're very familiar with that. So our technology is actually derived from power factor correction, because the power factor correction technology used today, because of the circuit limits, they are pretty big, and they are also a lower efficiency. So that means they cannot be used to tie to the battery, because their efficiency is very low, and it doesn't make sense to tie them to the battery, and also solar. But our circuit is very efficient. The peak efficiency can be the measured value we have right now is 99.2%. That's extremely efficient, and that means we can actually use battery and solar together with our inverter. So having that aside, it means that you just purchase one inverter and it can be used for many purposes.
Great, thank you. Is there any other questions?
I actually have one too. I know on the power factor correction topic, we have seen cases where somebody wants to use power factor correction capacitors, but there's VFDs in the system and it doesn't really allow the VFDs to operate properly with those capacitors in the way. I'm wondering if your system gets around that issue.
You mean the capacitor-based power factor correction?
Correct.
Yeah, we're actually use inverter-based power factor correction. So, well, we do use capacitor, but it's not the way traditional methods are using capacitors. So we have a smaller capacitor bank, and also because we have an inverter and we can control the power and the voltage, so we don't have the problem that you just mentioned with the capacitor banks.
Oh, very good. Thanks.
Okay.
Zhongyi, in your sector, is there some sort of industry-specific standard or specification like ASTM or something that is like the gold standard for your company and your competitors?
I'm not sure if I understand this question. For standards, there are lots of standards for electrical equipment, because for example, safety standard and also grid codes. We need to make sure that we won't inject bad harmonic currents into the grid. So yeah, there are standards, but I'm not sure what kind of standards you are referring to.
I could take this offline. In my background, I was a part of an electrochromic window manufacturer, and within that sector, there was an ASTM spec specifically made for dynamic tinting windows, and that was the sort of gold standard that a layperson, because I'm not a PhD in whatever you are, but there's sort of like a gold standard where someone, a layperson, could say, okay, this is how they stack against the competitors, if you have competitors, or there isn't one because it's so new, just to give someone just sort of a baseline understanding of their technology.
Yeah, I mean, I'll just hang around in the network session and we can discuss more for sure.
Yep, sounds good.
Great. So we have time for just one more quick question if someone has one. Otherwise, we will move on.
Here is Haitao. Yeah, I work for a home builder. We build net zero homes. I think your product is really interesting because one of the major problems for us is for net zero homes, we use air source heat pump. So the peak load, we always try to find ways to trim the peak load. So the things I just want to ask a very quick question. You are still in technology development stage, right? And then you want to have a partner to do a project. So I just want to know how far away your technology to, for example, I have a house and then to try your product.
Yeah, because we have prototypes at different scales and they are ready to test. But you know, we do need to have that the CSA certification, and we can do that in a much quicker way because you know they have this special inspection, just a one-time certificate for a pilot project, and we can do that. So it won't take us long to do a pilot project. And but I mean, if you want to see our products, I mean, on the market like a scaled up volume production, then we do need to have that you know official CSA certificate.
Okay.
Perfect. Great question. And exactly why we host these sessions to make and facilitate those relationships and those potential opportunities within our network. So thank you for that, Haitao.